Module 7, Section 6 finally gets us to something that's going to be a shorter lesson in this module. It is to write and solve one-step addition and subtraction equations. According to the pacing guard, this is going to be a mere 45-minute lesson. We're talking a single day. It's nice and refreshing after some of the more intense things we've had to do lately. Now our inquiry question asks, how does adding or subtracting the same number from each side of an inequality affect the inequality? It doesn't. It's going to be the same as it was before. The sign doesn't change direction. Nothing changes direction. Everything stays the same except for the values totaled on each side. So let's take, for example, here we've got this inequality, and we're going to take and add 2.6 to both sides, and what do you see? I'm sorry, that's an equality. 2.6 to both sides, everything still works. If I subtract 1.9 from both sides, everything still works. Now that's what the equality 5 is equal to 5. But what if they gave us an inequality? So now we're going to take and drag one of these and create an unequal situation. So let's say, I don't know, 5 is greater than 3.9. And you can see the greater than symbol right here. If we were to add 2.6 to that, guess what? The blue one's still greater than the green one. If I subtract a bunch from it, guess what? The blue one's still greater than the green one. You can add or subtract whatever you want from both sides, and it's not going to affect the way that the inequality is laid out. The alligator is not going to turn around and bite the person behind them. It's always going to stay the same. Now, an inequality is defined as a mathematical statement that compares quantities, unequal quantities, quantities that do not equal. They're going to contain the symbols less than, greater than, less than or equal to, or greater than or equal to. And none of these should be new concepts to you. If they are, take a look at the chart. But everybody should have dealt with those in their elementary school a lot. So let's keep moving on then and actually talk about graphing inequalities. That too should be a hard, fast, set in stone concept. You should have been doing that for a while.
To graph the solution set of the inequality, start by placing an open dot at 3.5. For an inequality that includes a less than or greater than symbol, an open dot is used to show that the number is not a solution. Next, draw an arrow from the endpoint. To show that values less than 3.5 are solutions, draw an arrow that points to the left. Consider another example. To graph x is greater than or equal to -1, start by placing the endpoint. For an inequality that includes a less than or equal to, or a greater than or equal to symbol, a closed dot is used to show that the number is a solution.
All right, let me pause that for a second because I want to point out something here. When it is not an or equal to, you hold a open circle. When it is an or equal to, you do a closed circle. Now climb back in your Wayback Machines and go back way back into elementary school when you first started plotting numbers on a number line. Did you plot an open circle or did you plot a closed circle? You plotted a closed circle because that spot equaled the number that you were plotting. Just like here, if it is an equal there, you're going to have a closed circle. If it's not an equal, it's going to have an open circle.
Next, draw an arrow from the endpoint. To show that values greater than -1 are solutions, draw an arrow that points to the right.
Nothing to do in these, guys. That should be a straight up review from when you were a little kid. Solving an inequality means finding the values for the variable that make the inequality true. You can solve addition inequalities by using your subtraction property of an inequality. You can solve subtraction inequalities by using the addition property of an inequality. And you already know how to do this because it works identically identical to when we were doing these with equations. It's going to say that when you add or subtract the same number from each side of an inequality, the inequality remains true. If we looked at that in symbols, if A is greater than B, then A minus C is greater than B minus C, and A plus C is greater than B plus C, and the other way around with the less than. And then an example of that, if 2 is greater than 5 and you subtracted 4 from both sides, 2 is less than 5, then you still get a negative 2, which is still less than negative 1. If 4 was greater than negative 1 and you added 3 to both sides, you get 7, which is still going to be greater than 2. It works just like an equation. But they can't make it too terribly simple with y'all. I mean, we already know how to do these things more or less, so let's have some fun and throw in some negative signs and some decimals for our first example, where they want you to solve 4/10 plus y is less than or equal to 9.6. Check your solution and then graph the solution on the number line. So let's take a look at how to do that. First thing we're going to do, what's your variable? It's y. Who's y's friend? 0.4. What is 0.4 doing to y? It is adding, but it's not adding because of this plus sign. It's adding because of the invisible plus sign that's in front of it. How are we going to make plus of 0.4y go away? By subtracting it on both sides, just like we did with equations. The 0.4's on the left are going to zero each other out, leaving you with, let's see if I can get it to work. All of a sudden my thing doesn't want to work here. Maybe if I move that. Nope. Well, that's weird. Well, for some crazy reason it won't let me type in my answers here, so we're just going to let it show it to us. From there, you get y left on the left hand side. On the right hand side, signs were the same, so they found the sum, which was 10, and the sign from the larger number went from the answer. So the solution for that was going to be y is less than or equal to a negative 10. To check that solution, you need to pick a number that would satisfy it. So, for example, if a number that's less than negative 10 would be negative 11. They plugged in negative 11 here, solved it, got negative 10.6 is less than or equal to negative 9.6. Is that a true statement? Yes, it is. So now we know we have a good solution there. Now the next thing that they wanted us to do is graph the solution. So let's zoom in a little bit. The point we're working with is on negative 10. It is an or equal to, so we're going to use a solid circle. And we're looking for values that are less than or equal to negative 10. So we're going to start on that negative 10. We're going to drag it to the left and let go, and it pops back. Our solution is correct. That's all there is to doing these problems. Now it's going to be your problem, only this time they gave you a fraction to work with. That's all right. You guys know how to do that. Isolate your variable using the addition or subtraction property of an inequality. Plug in your answer and then graph it to see if you're going to be correct here. Alright, so when I'm going to work it, I'm going to undo addition and subtraction by subtracting 3/4 from both sides. So I'm going to have a plus 3/4 minus 3/4 is greater than 3 minus 3/4. These, of course, are going to zero each other out, and that's going to leave me with a is greater than. Now, 3 minus 3/4, I can do that one in my head, but let's go ahead and show you why. I can change 2 or 3/4 become 2 and 4/4, because 4/4 is 1, 1 plus 2 is 3. And then subtract 3/4 from that, and that means my final answer is that a is going to be greater than 2 and 1/4, because 4 minus 3 is going to be 1. Jump back over to my solution. It's going to be greater than or equal to, right? Nope, it's just going to be greater than. Be careful about that. And what is it going to be greater than? It's going to be greater than 2 fraction 1 over 4, except, and check. That part checks. Now we're going to come down to our number line. We've got a positive 2 1/4. It's greater than it. It's not or equal to, so we're going to use an open circle. Starting on the 2 1/4, we're going to go to the greater than side because the alligator's eating the A. That means that A is bigger than the number. Check our answer. The answer checks. Nothing to do on these problems. For example 2, they're playing a little bit nicer for us because they are giving us integers instead of fractions or decimals, but it's going to work the same way. You're going to isolate the variable. Our variable in this case was going to be n, with n's friend being -5. We're going to make that -5 go away by adding 5 to both sides. The 5's on the right zero each other out, leaving n all by its wee little lonesome. And hey, it's going to let me fill it in this time. And then over here, -6 plus 5, signs are different. Find the difference with a sign in front of a larger number going in front of your answer. Now to check that solution, you have to find a value that matches. So we want a number that is less than or equal to -1. So a number less than -1 be -2. They chose -3 instead. -3 minus 5 was -8. Is -8 less than or equal to -6? Think about how your number line works. It is. Therefore, that solution is going to be correct. Now we're going to have to graph it on our graph. Same situation. We're going to start at -1. In this case, your variable is smaller than or equal to the -1. Because it's smaller than, we go to the left side of it. Because it's or equal to, we start with a solid circle, draw it to the left, let it go, and check. And the answer checks. There really is nothing at all to solving these problems. So we're going to reset that activity and move on to extra example 2, which is the last thing I'm going to show you in this video tonight. But we're going to start with part 2 after this one. You pause the video. Yes, I know they gave you fractions and mixed numbers, but you know how to do those. Go ahead and work on that one now. In doing this problem, my variable is going to be f, his friend is going to be 4/5, and 4/5 is subtracting itself from f. We're going to make that go away by adding 4/5 to both sides. So that's going to give me 3 1/5 plus 4/5 is greater than f minus 4/5 plus 4/5. These 4/5 just zeroed each other out, leaving f. The alligator doesn't turn around and bite the person behind him. And now we have 3 1/5 plus 4/5. Well, 1 plus 4/5, that's going to give me 3 5/5. And of course, 3 5/5, that just means it's going to be 4. So we know that our solution is going to be 4 is greater than f, which means then that f would have to be less than or smaller than 4. Check that. That checks. Scroll down here to graph it. We're going to plug in a open circle on 4. F is smaller than it, so from 4 we're going to go all the way to the left, let go, and our answer checks. That's all there is to doing these things. They're easy, aren't they? That's where we're going to end up stopping at for this video. When you come back to part 2, which I'm going to record at another time, you're going to start off with learning to write inequalities. We will see you then.